Hi, everyone. Let's go over these websites that I sent a link to, and I will make sure to post in the bottom of this YouTube video. So we have a convex pentagon here. Now, penta means 5, so 5-angled shape, and it's convex because all of our interior angles are less than 180 degrees. Okay, so a polygon has to be an enclosed shape that has vertices connected by sides. And we can have a convex polygon or a concave polygon. In this case, this pentagon has one interior angle that's greater than 180 degrees. So when we're dealing with polygons, we can connect diagonals from the vertices extending to all the other vertices that we can connect in the interior. So these diagonals are all going to be in the interior when you're dealing with a convex polygon. However, when you're dealing with a concave pentagon, not all the diagonals are going to be completely inside. So let's look at this little demonstration that we have here. We can select a 3-sided polygon, namely a triangle. And if we move the vertices around, we can see that the number of diagonals does not change. Now think about why is it that we do not have diagonals in a triangle? Well, a diagonal has to connect from one vertex to any other opposite vertex. From this point, from this vertex to this vertex, those two are already connected by one side of the triangle. So the equation to figure out the diagonals is n for the number of sides times n minus 3 divided by 2. And when we substitute n with 3, we get 0. Now let's look at a quadrilateral. So a quadrilateral has to have 4 sides. Okay, we can stretch this out. And as you can see, our diagonals are on the inside. But as soon as this shape is changed so that we have one angle that's greater than 180 degrees, one of the diagonals falls on the outside, and the number of diagonals, however, does remain the same at 2. And that's because the formula for determining the number of diagonals is simply based on the number of sides. It has nothing to do with the type of angles that are inside of this polygon. Okay, let's take a look at this 10-sided figure. So this is a decagon. And right now we have a regular decagon because all the sides are congruent and all the interior angles are congruent. Once I move one of the sides, notice that I went from a convex decagon to now a concave decagon. Now we just have a decagon because all of our interior angles are less than 180 degrees. But look at the network of all the diagonals. If you have a 10-sided polygon, you get 35 diagonals. That's quite a network to have. Okay, now let's take a look at this other website that I shared with you as well. And for this one, we can decide if we want a regular or irregular polygon. And you'll see how this matters more when you're dealing with something bigger than just a triangle. Okay, so here we have a convex irregular square. And If you move this around, now we have a concave irregular square. And you can see that this angle here has become greater than 180 degrees. Okay, I can move this around. Now we're back to a convex quadrilateral. And if I click regular, it's going to bring me back to a square. Here's a regular pentagon. Now remember, the definition of a regular polygon is that all the sides are congruent and all the interior angles are congruent. So once I try to move my polygon by moving the vertex, notice that if I have regular checked off here, all it's going to happen is that my shape is going to be dilated. So it's either going to shrink or it's going to stretch. If I check off regular, then I get still a pentagon. And so far it's still a convex pentagon, but the sides are no longer congruent. Okay, so I hope you find this interesting. Now let's check off regular again, and I'm going to show you something that happens. What are you noticing as we increase the number of sides? Okay, I can try to stretch it out again. You should start to notice that our shape is starting to look more like a circle. It's still a polygon because if I were to stretch this out, we still have vertices, but you can see that this is getting closer and closer to a circle. Okay, I hope you find this website helpful to visualize what happens between a convex and a concave polygon when you're drawing diagonals, and how the sides differ between a regular and irregular polygon.